In this video, we're going to keep talking about 8.4 Objective 2, where we're going to solve applications involving radian measure. Was just running out of space to work these last few problems out in the way that the questions were stacked and didn't give any workspace. So just set up here to work on the whiteboard for these last few problems. So I'll be copying the problem in each time here as we work through these problems. So this is problem number 12, a storm, which is 8.4, number 35 from the textbook. A storm causes a pilot to follow a circular arc with a central angle of 12.8. Let's see if I can get this drawing here, where there's the straight line path, and there's the circular arc. There's a thunderstorm here that is in the way of them being able to take the straight line path, and they have to go around from city A to city B. Straight line path here would have been 181.8 kilometers. We're going to try and find this. This is R and this is R, and we're told that this angle here is 12.8 degrees. So because this is an isosceles triangle, we know that we can split this in half here and make two right triangles. So let's look at either one of them here. This, where this is R, and this is going to be 181.8 divided by 2. It's going to be 90.9 kilometers. And that's going to bisect this angle as well. So where that angle was 12.8, now it's 6.4 degrees. And that gives us enough information to solve for R, saying that sine of 6.4 degrees is equal to 90.9 kilometers over R. So R is equal to 90.9 kilometers over the sine of 6.4 degrees. My calculator in degree mode here, and I'm going to have 90.9 divided by sine of 6.4. And I get an answer here for R of 815.4738563. So then I can solve for S and say that S equals R times theta, where theta was 12.8 degrees. Then I need to multiply that times pi over 180 degrees to change it to radians. Let's take this times 12.8 times pi over 180. And I get S is 182.1786.081. Then the question is how much further out of the way we had to go. So we want to subtract the original 181.8 from this. And the difference is 0.3786.080.737 km. And we're going to round that to the nearest tenth of a kilometer. So it's 1 decimal place is needed. So our answer is 4/10 of a kilometer. And that's it for number 12. Give me just a second to get number 13 up on the board. All right, so we've got in 2005, a planet was found to be revolving around a distant sun-like star in 300 or 3.14 days. The radius of its orbit is 3,700,000 miles. What is its linear velocity in miles per hour? So remember, linear velocity is equal to omega times r. So we're gonna need to find omega, where omega was the angle here that it's going divided by t. And so omega is going to be going 2 pi radians of full orbit in 3.14. These are Earth days times 1 day is 24 hours. So let's convert here. Can say that we have omega is 2 pi divided by, and then in the denominator is 3.14 times 24. And I get 0.0833756.012 radians per hour. So V is going to be equal to 0.0833756.012 times 3,700,000 miles. It's going to give me V is 308,489.7245 miles per hour. And I've got a little bit different number than I would round this and say this is 308,000 given the instructions here. But it said to round all intermediate values to the nearest thousandth. So I needed to round this to 0.83. And let's go back and make that calculation again, because then that's going to change my final answer. So 0.083 times 3,700,000. It's going to give me 307,100, and then rounding that to the nearest 1,000 will be 307,000 miles per hour approximately. So that's what we were looking for here, 307,000 miles per hour. All right, give me just a second to get problem 14 up on the board. All right, the blade of on a typical table saw rotates at 3,300 revolutions per minute. Calculate the linear velocity. So I'm going to have to change rotations per minute to radians per minute, an angular velocity. So this is going to be each rotation is going to be 2 pi radians. This is rotations per minute. Rotations will cancel. So 3,300 times 2 pi gives me an omega of 2734.51151 radians per minute. Our linear velocity is going to be omega r. And the diameter is 9 inches, which means that the radius is going to be 4.5 inches, since the radius is half the diameter. So my linear velocity should be 20734.51151 times 4.5. And I get a V of 93305.30181. When we round to the nearest tenth, I should get 93305.3, and this is in inches per minute, but I want to change that into miles per hour. So let's not round that just yet. This is in inches per minute. So V equals 93305.30181 inches per minute. We're going to change minutes to hours, and we're going to change inches to feet, and we're going to change feet to miles. There's 5,280 feet in 1 mile. So feet will cancel with feet, inches with inches, minutes with minutes, and we'll be left with miles per hour when we're done. Let's go ahead now and take this number times 60, and then divide that by 12, and then divide that by 5,280. And and I get V is 88.35729.338 miles per hour. And they want us to round this to the nearest tenth. So V is approximately 88.4 miles per hour. All right, give me just a second to get problem number 15 up on the board, and problem 15 will be our last problem for this objective and for chapter 8. So 1 second. All right, here we go. The turbine fan blade of a turbojet engine is 1.1 meter in diameter. So D equals 1.1 meters, which is going to be 0.55 meters and for a radius. And then our rotational velocity right now is 250 rotations per second. That's really fast. And we need to change this into one rotation is 2 pi radians. And so that's going to be omega 250 times 2 pi is going to give us 1570.796.327 radians per second. They tell us to round intermediate values to the nearest thousandth. So omega is 1570.796 radians per second. And then linear velocity is going to be omega r is going to be 1570.796 meters or radians per second times a radius of 0.55 meters. So 1570.796 times 0.55 is going to give me V is 863.9378. And they want me to round this to the nearest 10 as needed. So that's going to be V is approximately 860, and radians wouldn't matter. This is meters per second, and this is 860 meters per second. Okay, that covers all the problems from this objective. We'll see you next time for 9.1 objective 1. See you for the next video.